Next up, we're going to look at the planet Venus, which in many ways is remarkably similar to Earth, but in other ways, completely different. In fact, sometimes Venus is referred to as Earth's evil twin, and we're going to talk about why that is and what that even means. Now, there are a few things to note about Venus when you're looking at the night sky. It can be seen to be much brighter than Mercury, and it can also be further away from the sun. If you remember when we talked about Mercury, when you were looking to find Mercury in the night sky, it's always going to be relatively close to the sun. That's why the best time to see it is at sunup or sundown. Venus can be further away from the sun than that, and sometimes though it's called the morning star or the evening star because it is still tied to the sun. But maybe the most startling feature of Venus is how bright it is. In fact, after the sun and the moon, it is the brightest thing in the sky. And in the night sky, it's actually the brightest thing other than the moon. So that's one of the things that makes Venus easy to find, is just how bright it is. It's kind of funny in a way because the ancients named the planet Venus for the goddess of love, the Roman goddess of love, because it was so bright and luminous, and it was seen as this beautiful object in the night sky. So it was named after the goddess of love. But as we're going to see shortly, Venus is actually very hellish, as its environment is just an awful place. Not a place you'd want to go visit on vacation. Now, while Venus is the brightest object in the night sky, its brightness actually varies. And that's because it exhibits phases. Not exactly like phases of the moon, but the same sort of idea. We have the angle at which Venus is relative to the Earth and the Sun means that only parts of the surface of Venus is illuminated relative to us. And so you can see in these pictures here some of the different phases of Venus where different aspects are seen. Now, one of the things that you might remember from our discussions earlier about the heliocentric and geocentric pictures of the universe was that the fact that Venus has phases that behave in the way that it does can only be explained by the idea that both the Earth and Venus are orbiting the Sun. If Venus were orbiting the Earth, as was believed by ancient people, then the phases of Venus would be seen to behave very differently. But they're perfectly explainable by the picture of Venus orbiting the Sun and then the Earth orbiting the Sun with an orbit outside of Venus. And in this picture, you can sort of see how the different angles work. You can see that the sunlight's coming here, and that surface of Venus is illuminated only on the side facing the sun, but the Earth is over here. So the Earth does if the part of Venus facing the Earth was completely illuminated, we would see the whole round thing. But because a different part of Venus is illuminated relative to the line of sight of the Earth doesn't see the full illumination. It only sees the phase. And this picture shows how that works. But the big takeaway here is that one, Venus does have phases, and two, these phases can only be described by the heliocentric model of the solar system. Next, we want to look at some of the physical properties that Venus has. The radius of Venus is 6,000 kilometers. The mass of Venus is 4.9 times 10 to the 24th. Oops, there's a typo there. That should be 10 to the 24th, which is, of course, a 1 with 24 zeros after it, so the mass of Venus is rather large. That compares to the mass of the Earth, which is about 5.9 times 10 to the 24th kilograms for the Earth. So you can see 4.9, 5.9. The mass of Venus and the mass of the Earth is very similar. Venus is slightly smaller than the Earth, but of a very comparable size. The radius of Venus is about 6,000 kilometers. The radius of the Earth is about 6,500 kilometers, something like that. It's very close in size. So The densities are similar. So in many ways, Earth and Venus are like twins. They have, very, very similar physical properties. Now, there are some rather startling differences as well. And one of the things that is very interesting about the motion of Venus is that it rotates around its own axis in a backwards fashion relative to the other planets. In other words, if we look at this figure here, we can see all the planets are indicated, all the inner planets are indicated, Mercury, Venus, Earth, Mars. We can see that their axis is shown, so Mars and Earth have a nicely tilted axis relative to the plane of the orbit around the Sun. Venus and Mercury, their axes are not as tilted, but each axis you can see a little loop around it, and that's showing the direction which the planet is rotating about its axis. And Mercury, Earth, Mars, they all rotate in the same direction, but Venus is actually rotating in a backwards direction. And we call that kind of motion retrograde. Now, you might remember we've seen that term retrograde before. We talked about the planets moving in the night sky and how sometimes as you're watching, say, Mars go across the night sky, it seems to move backwards sometimes. And then we called that apparent backwards motion, retrograde motion. And we talked about how that's caused by the fact that the Earth and Mars are orbiting the Sun, and that was one of the things that made the geocentric model of the universe seem a little bit weird, because to account for that backwards motion you had to have all these crazy loop-the-loops, and that the Copernican model where the sun was the center of the solar system made things much simpler. But the main point here is that Venus has this backwards rotation relative to the other planets in the universe. Now, another thing that is very different about Venus is that as it rotates around its axis, it takes 243 Earth days for one Venus day. That means Venus is rotating around its axis incredibly slowly, and it's rotating in the wrong direction, or at least the backwards direction compared to the other planets. The only other planet that has a weird rotation like this is Uranus, and it's different from Venus's as well. We'll talk about that later, but most of the planets behave similarly to one another, but Venus is a stark exception. And nobody really knows why this is. And there have been some theories that have been put up, maybe some impact from some large object or several objects in Venus's different paths basically slowed it down and made it spin in the wrong direction. The other things that people have hypothesized is that maybe tidal forces with the sun has affected Venus. We've talked about how the tidal forces of the moon and the earth is slowing down the moon's orbit. It's not exactly the same thing, but an idea has been proposed that because Venus has such thick, dense gases in its atmosphere, that the tidal forces on the atmosphere of Venus is over millions and millions and millions of years has slowed it down and actually forced it to go in the wrong direction. But the truth is, we don't really know. This is one of the mysteries about our solar system that we have not yet solved. Why does Venus spin backwards? That's something that is still being considered, and people are still trying to figure that out. But the fact that it does spin backwards is a little bit weird, and it's kind of cool, actually. If you're a scientist, mysteries like that, they frustrate you, but they also excite you because it's just something new to explore, something to tackle and try to understand. Now, you might remember we've talked previously about the difference between a solar day and a sidereal day. That has to do with the fact that the planet is orbiting around the sun, and if you have a stick lined up with the sun, say at one point, say that would represent like basically noon, right where the stick is, the sun would be directly overhead. And if the planet were not moving, if it were just spinning about its own axis and not moving relative to the sun, it would take a certain amount of time for the planet to make one complete rotation and for the stick to line up with the sun again. But because the planet is moving about the sun, if the planet is here, in the time that the planet has moved from here to here, the stick is not lined up with the sun. And so we can talk about the solar day, which is the time it takes for the planet to go all the way around its axis, or the sidereal day, which is the time it takes for the stick to line up again with the sun. And we've talked about that previously, and you might remember that I don't really care if you know that distinction. That's a little bit beyond the scope of what I care about in our course, but that's what it is if you are interested. Now, let's talk about the conditions on Venus. What would it be like to be on Venus? Because I said that Venus was, in some ways, Earth's evil twin. And it turns out that Venus is pretty much what most people imagine hell to be like. First of all, the atmosphere of Venus is primarily made of carbon dioxide. So if you were to teleport to the surface of Venus, the air there would not be something that you could breathe. So you would immediately start choking and gasping for air. But that wouldn't last long because the atmosphere is also incredibly thick. It's so thick and so dense that the atmospheric pressure on the surface of Venus is enough to basically smush you like a grape. So if you were to magically teleport to the surface of Venus, you would start choking and the pressure would crush you. Now, as you were having your insides squeezed out of your body, the temperature is about 730 Kelvin. That's close to 900 degrees Fahrenheit, and it's hotter than the surface of Mercury. The surface of Venus is almost 900 degrees Fahrenheit, 730 Kelvin, and basically you would be smushed like a grape, you would be choking on the atmosphere, and you would be roasted into effectively like a charcoal briquette. But if you could somehow survive that long enough to try to escape, maybe rise up beyond the surface, as you would go up into the atmosphere, you would find yourself being dissolved by acid rain in the sulfuric acid clouds in the planet. This is not a place that you would probably ever want to visit. Now, I mentioned how dense the atmosphere is. Even probes that we have sent to fly around Venus, they can't really see the surface. Infrared, ultraviolet, visible light, they're all blocked by this incredibly dense atmosphere. So we cannot really see the surface of Venus from above it or beyond it because the atmosphere is just so incredibly dense and thick. Now, as we continue talking about the different features of Venus, one of the things that's interesting is that its surface is relatively smooth. Now, how do we know that? I just told you that we can't see through the atmosphere. Aha, well, that's something we'll talk about in a minute. But two things that we do know about the surface is that there are two very large continent-like features. One of them is called Ishtar Terra. The other one is called Aphrodite Terra. Now, those names are a little clever, I think. Aphrodite was, of course, the Greek version of Venus, the Greek goddess of love. And Ishtar was the ancient Mesopotamian goddess of love as well. Interestingly, she was the goddess of love and war, so those two things were maybe not viewed as very distinct by the ancient Mesopotamians, which I find a little bit funny. But anyway, that was why those two continents were named that, because Venus was named for the Roman goddess of love, and the two big continents were also named for different goddesses of love. Now, we've talked about plate tectonic motion on the Earth. As far as we can tell, there are no plate tectonics, so you don't have continental drift on Venus like you do on the Earth. There are mountains, there are some craters, but there are many volcanoes, huge numbers of volcanoes. That's one of the ways that Venus is very different from the Earth, is just the vast number of volcanoes. There are thousands of volcanoes on Venus. So that's one of the ways that Venus is somewhat different from the Earth, is just the sheer number of volcanoes that it has. Now, here we see a surface mosaic of Venus, and this is a little bit misleading because you see the blue, and some people might see this blue and think water, but actually, this is like a relief map in a certain sense. It's showing different elevations rather than the presence of water. And so you can see these green regions where it's elevated up higher off, and then there's lower surfaces below. And this is an interesting picture. Now you can see here again we have this elevation map. We can see the different colors and what elevation they represent. Here we have the Earth, and of course you're all familiar with the map of the Earth. Here's North America, South America, Africa, Europe, Australia, etc. This is what a flat map of Venus would look like, and you can see it down below a little bit more easily because it's bigger. But you can see the main continent features, and you can see the different elevations of those continents. Here you can see an image of Ishtar Terra, which is one of the two continent-sized features on the surface. And you can also see here we have what's called Maxwell Montes, which is the highest mountain on the surface of Venus. So that's the maximum height that you can get on the planet, is to climb that mountain. Just to show you the scale, here's a little box here that's been blown up, and you can see that this scale is 50 kilometers. So this is a very, very huge feature. And the other continent is Aphrodite Terra, which we can see here. Now, this seems like a pretty good breaking point, so we'll stop here, and then we'll continue on talking about Venus in our next video.